Okay. So hello packets contents are these: router ID, area type, area ID, subnet mask, and hello and their interval. So in this, router ID has to be unique. We cannot have same router ID configured. Area type, it has to be same. We cannot have different area types. So area types, we have normal, stub, totally stub, NSSA, and totally NSSA. Area ID, the area number, it has to be same. Your area ID, you can either give in the format of 32-bit binary decimal value, I'm sorry, a 32-bit value, or else you can also give it as a decimal value. There's no restriction on configuring like this. Subnet mask information has to be same because your subnet mask is always used whenever you enable network command, right? Based on SM mask only, either I will send out an hello packet or I will not send out a hello packet. So SM mask information is very important. Even your MTU value has to be same in certain scenarios because OSPF does not support fragmentation. So if your MTU in the path or the neighbor guy is not same, in that case, as my OSPF will not support master transfer unit, does not support fragmentation, so it won't work. It will stuck in start state. Hello and an interval, it has to be same. It cannot have two different values. So I believe by now OSPF lab is ready. Okay.
Okay.
So let's enable OSPF between R1 and R2. And as you know, OSPF has multiple states. It starts from down, init,
Init,
attempt,
two-way,
yeah,
extract, exchange, full state, lower state.
loading and full.
Loading and full state.
Yeah. So in start state only, start state, we are not like, we are just starting to elect who is my, who is a slave and who is the
Master.
master. Why? Because I want to find out who will share the database first. That information is needed. And that election happens in start state. In exchange state, the router R1 and R2 will be exchanging the information what they have. It's like window shopping. They are not updating it. Updating is different, exchanging is different. A lot of people say they're exchanging LSAs. It's not like that. They're exchanging the LSDB informations. If anything is missing in R2, which R1 knows, and which R1 showed to R2. So in that scenario, a package will come from R2 called LSR, link state request packet. For that, my R1 will respond back saying link state update. For that, again, R2 will inform back link state acknowledgement. So these three packets flow under the update pack, loading packet. So under loading, we have three packets: link state request, update, and acknowledgement packet. Okay, so let me check my neighborship. Show IP OSPF neighbor. Okay, now I'm in attempt state. Attempt state normally comes when we are using NBMA network, non-broadcasting multi-access network. So in that case only we have attempt state. Why attempt state? Because you have to manually configure the neighbor. Let's say it's attempt dr other. Let me check the interface type. So the interface type on FA0/0 and 0/1, it has to be same. So let's check what I have here. Show running configuration, interface FA0/0. This side I have configured as broadcast. Okay. Show running configuration interface FA0/1. This side it is non-broadcast. So as you can see, when you have different network interface types, then also your OSPF will have some problem. As I said, it has to be same. It cannot be different. Again, I'm in attempt state, and show IP OSPF database. So this is the database which you can check on my router. This is like kind of your topology table, nothing else. So as my R1 is part of two area, that's why you're seeing area 0 router LSA and area 1 router link state LSA, as you can see here. But in R2, if you check, you will see only area 0 information. Why? Because R2 is not part of any other area. It's a backbone router. Show IP OSPF database. I do see only my information. I don't see any other information. So let me show you one small thing. I will enable R3 also, and I'll shut down this FA0/0 interface and 0/1 interface on R1. Then I will show you the number of LSDB number of router LSA, link state LSA you're going to observe. So so you know about this router LSAs, link state LSAs, right? So let me tell you how much will be there. So normally the type 2 LSA, I think the network LSA will be there. The number of network LSA is equal to number of DRs we have. So between R1, R2, R3, any idea how many DRs will be there? No, there will be two DRs. So DR is equal to 2. Why? Because every broadcast domain needs a DR. So normally for one broadcast domain, we'll having one DR. Because I have two broadcast domains here, we'll be having two DR. So because I have two DR, number of network LSAs will be much. Number of network LSA will be again 2. Because each DR generates one network LSA. Router LSA will be how much? 1, 2, 3. Every router in the network generates one router LSA. There will be 3 router LSA. So like this, we can compare the output what you're gonna get. So let me open back CLI R3. Okay. Let me shut down the FA0/0 interface. Interface FA0/0 shut down. R1 interface FA0/1 shut down. That's it. If you go back to R2, check show IP route. Do I see 12? Yeah. In R1, do I see 23 network? If I see 23 network, in that case, my OSPF is running good. Show IP route. 23, I don't see anything as of now. I do see my network, which is 1.1.1.1, which is my loopback IP. But I don't see 2 and 3. What happened? Let me check. So, do I have OSPF neighborship? Show IP OSPF neighbor? No, I don't see OSPF neighborship. What happened? Let us check. Show IP OSPF neighbor. I do see neighborship is not there with R1, but still I form neighborship with R3. So between R1 and R2, we're having some problem. Let's use debug IP OSPF events. Let's wait for some events to occur. And yeah, now there you see some information. It says I received a hello from 1.1. Okay. It says mismatch hello parameters. Okay. Let's check out what parameters mismatching. Okay. Fine. Now you got it. So whenever there is a mismatch in this network types, right, you always see the mismatch in hello parameters first thing. And what is mismatch? Here you can see it's showing the remote end hello identity interval is 120 seconds. Okay. And my end, dead interval hello is 1 and sorry, should be okay. Dead interval of remote, dead interval of current router. Hello interval of remote, dead interval of connected one. So now it's 40, it's 30, sorry, 40 and 120, 10 and 30. There is some problem, right? So normally the non-broadcast, the broadcast value, hello broadcast network, hello will be 10 and dead will be 4 times that, which is 40. And non-broadcast multi-access, the hello will be 30 and dead is 4 times that one, which is 120. That's what mismatch is happening, right? It says mismatch in hello parameters. So as I said, you can check out the hello parameters, whatever you have here. Something is mismatch, and that we are clearly sure about the mismatch in hello parameters. So either I can configure manually the different hello and read interval, or else I can change. Let's try to change this timer itself. Now, how do I check my timer? Show IP OSPF. Um, show IP OSPF label. Show IP OSPF interface FA0/0. Do you see timer here? Yeah, here it is. That should be. It says 10 and 40. If I check on neighbor interface FA0/1, show IP OSPF interface FA0/1, here it says 30 and 120. That's the problem here. Yeah. So why there's a difference? Because network interface type is different. Here it is non-broadcast, but his side is broadcast. So let's make this side as also broadcast. Fix it. Interface FA0/1. And how do I change the network types? So command is IP OSPF network broad. Put a question mark. Because I'm configuring that inside my interface, right? So you don't need to give process ID. Okay, that's it. Now I said he's a broadcast. Now you can quickly see that my OSPF status went into full loading and then full. So now I should see my 23 table information inside R1, right? Show IP route. That was a problem. Now I do see it. Now can I ping him 23.003? And my IP address assignments are very simple. Between R1 and R2, I'll be using 12 network, saying 12.001 here, 12.002 here. Between R2 and R3, I'll be using 23.002 and 23.003. Between R3 and R5, 35.003 here, 35.005. So my IP address assignment is equivalent to your router name, router number. So now how many router LSA and how many network LSA I should see here? Show IP OSPF database. Here you can see how many routers are active now, R1, R2 and R3. So I'm saying 3 router LSA. And who is advertising my network LSA? It says advertising router ID is 1.1.1.1. Why? Yeah, let me check why. Show IP OSPF interface FA0/0. It says DR. Who is DR?
1.1.1.
That's why I'm saying I'm generating that. So if you go and check about this information, show IP OSPF, no, interface we have to check. Show IP OSPF, show IP OSPF interface FA0/1 include ID. It says for this process ID, router ID is what? 23.002.
And DR is 1.1.
Router ID, my router ID is this, and for my network, DR is that guy. So that's why DR generates the network LSI, not other routers. Now it says some more information also. It says one more DR called 23.002. It says that guy is advertising. Maybe he's also a DR, but not for this network, for this network, R2 and R3 network. So if I check FA0/0, I will have another DR election. Here it says my DR router ID is 23.002. Simple. So let's tune the DR now. So now how do I change my DR router into DR number informations? So you can go inside interface. I'm sorry. You can go inside router OSPF 10 and say router ID. I'm sorry. You have to change the router ID. So router ID I want it to be 2.2.2 just to be consistent. So once you change router ID, immediately your router ID will not change. Why? Because your router ID election process happens only once when you are configuring the OSPF newly. Whenever the process starts initially, then only your router ID election happens. So because of which it will not happen. So you can say the router ID election is non-preemptive. So it will not happen once you configure something. So you have to clear the IP OSPF process, then say yes. After some time, again the process will restart, and this time it will take the router ID as 2.2.2. Now it says my router ID is 2.2.2. Exactly. That's it. Let's change here also. Router OSPF 10, router ID 3.3.3. Clear IP OSPF process. Okay. So let's change one by one. Let's have some wrong configuration, and we'll have a look at it. What is happening? So on R2, I'm going to run the debug command, debug IP OSPF events. I will change one by one. Before that, let me show you the hello packet content in the Wireshark capture. So let's check one hello packet, anything. So if you open this OSPF open short path as hello, it has three information. One is header, hello packet content, and
LLS.
LLS link level. LLS, I'm not sure. What is that? Let me check. Okay, just have a checksum. Okay, let's have a checksum informations. So if
Okay.
you open hello packet, you will have your network mask, hello interval,
Hello interval.
leave the options field as of now. Router priority is there, by default is 1. Then interval,
Router
DR
then interval.
router, BDR, active neighbor, everything is as. So under hello packet, you have all the information. Under header, you'll just have the information about your source router.
Versions.
Yeah, version is by default. By default is 2. If you're going to use for version 3, which is nothing but IPv6, you have to use version 3. Just for
Okay.
small information, initially when version 3 was launched, it was launched only for IPv6. Now version 3 supports address family configuration. Because it supports address family configuration, you can simply type address family IPv4 and you write a neighborship for network statement for IPv4. Then you can configure address family IPv6. You can configure IPv6. So do you aware of address family stuff?
Okay.
Okay, same. So now area ID it has. So your header will not have that much information. Only your OSPF hello packet has that much information. So let's try to change or alter some stuff. So as I said, I should have a unique router ID. What if I configure same router ID on R2 and R1? Let's see what happens. R2's router ID is 2.2.2. So configure terminal. Router OSPF 10. I'll say okay. Router OSPF 10. I'll say router ID is already 2.2.2. Clear IPOSPF. Sorry,
First.
clear IPOSPF process. Yes. Now immediately you see some LS update packets having some problem.
Okay.
Says and even R2 will start throwing some error. It says end of hello processing. It says the component which calls up here and debug all is this component duplicate router ID NBR. Duplicate router ID neighbor is the syslog component which is triggering that particular message. It says OSPF directed duplicate router ID from that guy. So whenever you have duplicate router ID, what will happen? Show IP OSPF neighbor or clear IP OSPF this old entry neighbor.
Okay. OSPF.
Okay, now it went off. Show IP OSPF neighbor. Now it is in down state. So whenever you mismatch in router ID, what will happen? In down state, the hello packets are flowing, right?
Okay.
In down state, I don't care about neighbors hello router ID. I don't care about my router ID also. But in each state, the exchange start receiving the hello from neighbor. And also in this two-way state, we actually compare the hello packet router ID informations. So because that is happening here, your OSPF is in down state now. So you cannot have same router ID. So let me fix it. May not may IPOSP IP debug IPOSPF events. If you go to R1, let me fix the problem. Now let's create a problem of having different SM mask information, subnet mask information.
Subnet.
So router OSPF 10. I'll say router ID is 1.1.1.1. Clear IPOSPF. Okay, now we don't need to write. Let's wait for some time. Why? Because even though my router ID is different, right? They keep on sending hello packets. So your election of router ID haven't happened now. So now they because of duplicate IP, they are just waiting to get new router ID. That's what OSPF works. OSPF says that hey, engineer, I'm having some problem. You fix it. Once you change that information, I'll update myself. So just for our information, we can clear it, but still your OSPF becomes up. So we no need to manually clear it whenever you are when there is an actively issues happening because actively my router is working on to find out a unique router ID something like that. So let's change the interface IP information, nothing but SM mask information. That is also a component in hello packet, right? Where is it one? It should be somewhere here. OSPF header, LS update. Here it is, net mask information. Under the LSA update, you will have your network as net mask information. It has to be same. Now, what if you said I configure /8? Let's see what happens. Interface FA0/0, IP address 12.001, 255.0.0.0. And now let's see. Show IP OSPF neighbor. Again, the OSPF went down. Why this time? Because your OSPF hello packets, right? That guy's router net mask is not same, which is also one of the component uh, we have in hello packet. So now it says no, I can't form neighborship because the net mask is not same. The subnet mask is not same. So let's fix this. Let's have an event lookup here. It says some election blah blah. Here it is. See, do you see mask different information here? 255.0.0 is what removed, but my connected is 255.255.255.0. So you can troubleshoot almost all the possible issues of OSPF using the single command debug IP OSPF events. So let's okay. Let's fix this command. And now this time, okay, we saw about network ID, so network type. We saw about subnet mask. Yeah. Then we saw about router ID. What is hello time and read interval is different. In that case, what will happen? Let's check out that. Interface FA0/0, IP address 12.001, 255.255.255.0. Now IP OSPF, what the value? Their interval or what? Hello interval? Yeah, hello interval. So I'm giving for 30. Okay, enter. And I'm going to give their interval as 4 times. Their interval maybe 120. So now there is a hello timer mismatch, right? So in that case, what will happen? Again, the problem will arise. Show IP OSPF neighbor. Let's clear the process. Clear IP OSPF process. Yes. Okay. So here you can see the information of timer mismatch. So here also you can filter the OSPF packet alone. See, in Wireshark, whenever you want to filter the OSPF or loop, this protocol wise now, just need to type OSPF here and hit enter. That's it. You start seeing only OSPF packets, nothing else.
Okay.
Okay. Now let's see what this guy throws. It says some sending hello, sending hello. It says mismatch hello parameters again. Immediately after that, it shows the information what is mismatching, right? So that's why I am not able to form neighborship. Let us fix this. 10 and 40. Okay. So similar to this, whenever you have the area uh, type mismatch, like one side stub area, one side not so stub area, obviously it won't form. It's obvious that if an area number is also mismatched, in that case also, it will not form. Maybe interface FA0/0, I'm configured under area 1, this side area 0, it won't form. It has to be same area. Now let's learn about the virtual link concept. So virtual link we normally use whenever we have an area which is not directly connected to my backbone area. And the OSPF RFC says that all the non-backbone area should have direct connectivity with the backbone area. And if it is not, in that case, it is considered to be a bad setup. And you can fix the problem. We can fix it by just configuring a virtual link. But understand why. Why I can't just go like this. Very simple concept which I read in RFC, reason for comments of OSPF. It says a definition for ABR. Clearly they say that area border router is a router which is normally used to convert type 1 LSAs into type 1, type 2 LSAs into type 3 LSA. Right. And ABR routers are the routers which are connecting area 0 and an area X non-backbone area. So in RFC they never said that the area border routers are the routers who are connecting two different areas. Area 1, Area 3 is being connected by R4, but we cannot say R4 as an area border router officially. But normally we can say because it's connecting two areas and it's lying in the border. But officially we cannot say it as an area border router because ABR routers are the routers who are connecting non-backbone area to the backbone area. So R1 can be said as ABR router. And this line says that only ABR router we can convert has the tendency to convert type 1, type 2 into type 3. And type 3 LSA is the only LSA, the first LSA in the process, which has the power of flowing between areas. Normally the type 1 LSA, this guy is within area. Type 2 also within area. Type 3 LSA, it can flow between areas. And type 4, entire OSPF domain is the process. Type 5 also entire OSPF domain. If I'm sending on type 5 from here, AHRP I have, if I'm sending or redistributing type 5, this type 5 will go all the way here because it can flow all the areas, entire OSPF domain. So let's fix the problem. Let's observe the problem, what we're going to observe, what we're going to see without configuring virtual link. I believe I have to remove this line of configuration which I already have here on R4, or else it will remove in R1 directly. Just one line configuration. You just need to inform the router R4 and R1 that you form a virtual link from R4 to the neighbor's router ID. Normally people do mistakes by just configuring the neighbor interface IP. No, you should not configure, you should not call here neighbor interface IP. You should configure the router R1's router ID. Normally mistakes has been done like this a lot of times. So let's go back to R1. Let me remove the virtual link configuration what I have here. Router OSPF, router OSPF 10, no area 1, virtual link 4.4.4. Finished. Let me open R4 and R6 CLI also now. So in R6, let me check the routes. Am I learning about tool or not? It's obvious that I cannot learn. Let me check if my neighborship is up. Show IP OSPF neighbor. My neighborship is up, but still I can't learn. Maybe R4 is not giving anything to me. Let me check my database. Show IP OSPF database. Okay, R4 is not giving anything because about area 1 information I should see in the type 3 LSA, right? I don't see anything because maybe R4 is not converting anything to type 3. Let's check out R4 now. Show IP OSPF neighbor, and it says I form neighborship only with R6. Okay, they don't have neighborship itself. Let's check out what's wrong here. So let's check on R1. Maybe yeah, because I shut down the interface, right? FA0/1. Let's imagine that you don't know that in the live environment, we don't know that, right? If neighbor is shut down or not. Maybe you don't have a control. Then how do I inform my area 0, maybe ISP guy, enterprise customer that, hey, your neighborship interface is shut down. Let's check out troubleshoot from our end, from R4 only. So first command, I will check show IP OSP of neighbor. I see I run from neighborship. Now I have to prove that my end configuration is good, your end is faulty. So let's check out the running configuration. First, we are not even sure on which interface also, right? By this way, you cannot be sure. Let's run this command. Show CDP neighbor. Show CDP neighbor. I see my neighborship is formed. I don't see any neighbors apart from R6. So there is some problem. Let me check on which interface I have enabled OSPF. Show IP OSPF interfaces. It says that I have enabled OSPF on FA0/0 and local interface which is connected to R6 is F faster than 0/1. And I say I enabled OSPF on FA0/0 and I also enabled OSPF on FA0/1. Now I can decide, come to conclusion that this guy is having some problem. So here we have configured OSPF, but still I don't see anything. Let me check what happened. Am I suppressing any hellos? Am I rejecting any hellos? It says no, you're not rejecting any hellos. Then let me check out about this interface. Is it up or not? Show IP, show interface FA0/0. It says LAN status is up, admin status is up, and LAN protocol status is also up. It says no issue I have. What should be the problem? Then you should check. Then similarly, then you should check the whether am I receiving hello packets or not. Am I sending hello packets or not? That will be the first step troubleshooting. How do I check hello packets I'm receiving or not? We can simply say show IP traffic. This command can give you a brief details about all the protocols running on your network, and there comes your OSPF. So let's copy down here. Let me check a section of OSPF. It says received 50, and it has only received information, right? Yeah, I think I should not give this section. OSPF sent and received. Yeah, it says I'm sending 91, but I'm received how many? 51. Maybe there's some issue. Let's again check. Is it changing now? You say 53 is being received, but sent is 93. It seems I'm sending a lot of double the number of packet, but I'm not receiving from one neighbor. Now you can easily guess that okay, that neighbor is what not responding to me. Let me check. Show IP OSPF. Um, show IP OSPF neighbor. I'm sorry. Show IP OSPF. The command is 10. There you can see the traffic informations. All it's a big output command, but you don't need to worry about this command. This command is what we saw in the show IP traffic output. But now I'm checking only for a specific interface. Okay. So let's go back up slowly. And it says my router ID is 4.4.4.4 and process ID is 10. First information what we got. And it says there is no header errors. You have to check on this information also. It says there is no empty mismatch. There is no hello. Hello says 0. It's actually counter. Okay, you have to make sure everything is 0. If there is an issue, this will be the possible reason for your failure of OSPF. And here, if you go,
reason is that it increase the numbers, right?
yeah, counter will be 1, 2, 3. It will keep on increasing. Yes. Okay. Now here you can see on the interface FA0/0, I'm receiving how many packets? It says I'm receiving 0 hellos, but I'm sending 47 hellos. Okay, that seems to be a problem of receiving the hellos. On interface FA0/1, I'm sending 47, 48. Now it proves that I'm not receiving any hellos from the neighbor guy, right? So you can clearly blame them that, hey, I don't have any problem, just that you're having some problem. And you can confirm that if they say that, hey, maybe you have some issues in your OSPF configuration or maybe interface issues there, then also you can confirm saying that, hey, we are 0 issues, just that we're not receiving hellos from the neighbor. And yeah. Now, how do you check if I have neighborship, or, I mean, if I can reach that IP or not? You can simply ping and check whether you can reach that IP or not. So at last, I'll be doing this command saying ping 14.001. The ping is not going. It'll say the OSPF is not, the interface is not up or something. They will decide whatever they want to do. Let's go back to R1 and let's enable this interface. Show configure terminal interface FA0/1, no shutdown. Now the interface is up. Now if I go back to my R4 and check if the ping is working, the ping is working.
Yeah.
Now OSPF is also up. Everything is clear. If I go and check database here, still I do see that database router LSAs are coming. I don't see type 3. Okay, I see type 3 also here. So I see the information about 14. Type 3 I can see. But on R1, if I could check show IP route, do I see 46 anywhere? No, I don't see 46 anywhere. Why? because of your what is this? Because in the backbone, the area 3 where I have 46 is not directly connected, somewhere else. That was the issue, and the same issue you can see in the syslog messages also. It says the component who is raising this in syslog is OSPF 4 error CV error received invalid packet. It says mismatch area ID from backbone area must be a virtual link but not found from 14.004. Okay. Let's check show IP OSPF database. Here you can see some information here, right? 46 dot something something. But still, I don't see this in my problem table. Why? Because my OSPF says that, hey, I can learn this information, but it's just that you have to configure a virtual link, which I'm expecting to you to configure.
Okay.
So by this way, you can confirm whether a route is in having some area ID mismatch or virtual link need to be configured or not by seeing the route which is not being learned in my order table, but I still see in my database table. So let's fix it. The fixing is very simple. You can go to R4 and configure a virtual link. I'll say router OSPF, router OSPF 10. I'll say area 1 virtual link to whom with 1.1.1.1. Just need to give the area which I have to cross. I'll go to R1. Let's say configure terminal router OSPF 10 area 1 virtual link to
Virtually 4.4.
finished. So with this line of configuration, your OSPF should be up and running. It says OSPF virtual link from loading to full. OSPF VL is a component which is reading the syslog messages. Now if I go back to here, if I check show IP route, now I do see 46 here, nicely. So let's go back to R1 and check something. Show IP OSPF 10 traffic. Let me just check quickly whether if I have empty mismatch, is it increasing or not? Because I'm not sure about the live device they increase, but not sure about this guy, virtual devices. So empty mismatch should not happen. MTU has to be same because as I said, OSU does not support fragmentation. So MTU, let's make it as 1510 maybe. Clear IP OSPF, OSPF process, yes. Show IP OSPF neighbor. It's stuck in exchange state. Yeah, normally it's stuck in extart state even there is a empty mismatch. It says exchange DR. Okay, it says something. Okay. One important information about MTU. See, this side I'm stuck in exchange state. Why? Because my end MTU is what? 1520. 1500 is the neighbor guy. Okay. For me, he is good. I mean, for him, I'm the worst. Why? Because under 1520, I can receive 1500 bytes of packets, right? I don't have any problem. But he will have problem when I'm sending 1520. True. If you go to R2 and check the show IP OSPF neighbor, check his side. I'm stuck in extart and debug all. So this also you have to verify. The side which is stuck in extart will always have lesser empty value. Why? Because
The
I
bytes.
cannot, yeah, byte access. The MTU size mine is smaller compared to yours. The
Okay.
side which is stuck in exchange state will be having higher MTU always, global row. So let me check out my traffic information. Show IP OSPF 10 traffic. Do I see empty mismatch here? No, I don't see it. Okay, maybe which interface I'm checking. Okay, here it is. It says some duplicate. It says hello and hello mismatch. Empty mismatch is not coming here. It's still increasing. Let's filter with this one. Empty. In the real-time devices, if you check, you'll see that the count is getting high. Yeah. Here I don't see anything, any issues. Okay, so that's it. Now what else we have? Let's talk about redistribution. And in redistribution, I just want to talk about one small component about the seed metric. seed metric. And networking. So seed metric nothing but default metric what an route will get when they are redistributed into some other protocol. So imagine that I'm redistributing any protocol route, any other protocol route into OSPF. So it will be 20 for all except BGP. So by default, my metric will be 20 except BGP. Only for BGP redistribution, I'll be making it as 1. Why, how am I saying is, imagine that you're distributing, I have OSPF network here, and you have an EIGRP network, maybe it's a different color I can put. You have EIGRP network here. So when you're distributing EIGRP into OSPF,
It take 20.
yeah, it will be 20 because of seed metric. But you can also change it. Seed is default 1. If you redistribute anything into RIP, it is infinity. You have to give. Without this metric value, you cannot redistribute anything into EHRP and RIP. If you do now, it won't happen. That you can try later. If you try to redistribute anything into EHRP, by default, it will say, I don't even know about that guy. I won't reach. Until unless you have to give manually the metric values. But OSPF, BGP, these people are smart. BGP, very simple. Whatever IGP metric is there, it will take that one. But OSPF, except the BGP, which is 1, will be the metric. Other thing by default will take as 20. So let's redistribute EHRP into OSPF and check out this one. This is called seed metric. Let's not copy this. Okay, let me redistribute here R5 and R6. So here I'll show to redistribute EHRP into OSPF. So when I do OSPF into EHRP without giving any metric value, redistribution should not happen. Why? Because of seed metric, which is there. Yeah. So let's open R5 and R9. Okay, it is R5. It is R. That is R9. R9. So let's go back to R5. I'll just check the adjacencies if everything is good. Show IP OSPF neighbor. I don't see anything here. Let me check the configuration on FA0/1, or let me check the OSPF configuration. Show running configuration, section OSPF. Did I enabled for 35? Yes. What about R3? Show running configuration, section OSPF. Okay, here I have not configured anything. That was the issue. So let's configure now. Router OSPF 10. I'll say network 35.000.000.255 area 0. That's it. WR. I'll go back to R5 and check OSPF neighborship. Still I don't see anything. Let me check interfaces. Show IP interface brief. Okay, can I ping 35.003 or is there any problem? Yeah, I don't ping that guy. Let me check what happened. R3. Show IP interface brief. 35.003 is admin down. That is the issue. Let's bring that up. So interface FA. Okay, no shutdown. That's it. Now I should be able to ping from R5 to R3. Ping is working. Is it my OSPF up now? OSPF is also up. So let me check my EIGRP neighborship. Show IP EIGRP neighbors. My EIGRP, it says sequence number 3 is showing. That means it's up. It should not be 0. If it is 0, then there is a problem. Now R9 also you can check the same. Show IP EIGRP neighbors. Again, it shows some sequence number 4. That means so EIGRP is up. Let me check my routing table. Show IP route. Okay, I know I do see some of the routes are being learned. It says D means D means what? EHRP. It says external routes. So that maybe I redistributed already in R5. Let me remove this configuration and show it to you. So configure terminal. If you check the EHRP configuration, show running configuration section, EHRP, configure terminal, router EHRP 10, no redistribute EHRP 10 subnets. Sorry. No redistribute OSPF 10. That's it. Let me verify the configuration. Okay, now I don't redistribute it. I'm just, well, I'm not sure why redistributing EHRP inside EHRP. Okay, wait, who cares? So let's go back here. Now I don't see anything here because I stopped redistributing my OSPF into EHRP. So do I see 59 in R3? We check, do I see 59 in R3? Yes, I
No.
do see.
No.
Why? Because we have redistributed EHRP into OSPF. There is two distributions. There are two distributions. One will be you have OSPF here and you have EHRP here.
Yeah, yeah.
You have to distribute EHRP into OSPF and OSPF into EHRP and EHRP into OSPF. So this is done. So EHRP into OSPF is done. That's why I'm showing my EHRP routes here as an external type 2 routes. And by default, OSPF will take,
Two EIJR.
yeah. So by default, we'll take it as E2, which is external type 2, which is the default one, where we have E1 and E2 routes in OSPF. By default, E2 is preferred, and A2 has the cost value of my ASBR to reach my external route. If I say E1, in that case, it has both the cost value of me to reach ASBR than the ASBR to reach that guy, I mean the external route. So let us quickly do the redistribution, but this time I will not give any metric value. Let it be seed metric by default. So configure terminal, router EIGRP10, I'll say redistribute OSPF, give the process ID 10. That's it. Now if I go to R9 to check, do I have any routes? It says none. Even though I redistributed, I don't say anything. Why? Because of EHRP seed metric, which says that by default, if anybody is distributing inside me, the metric value is infinity.
Infinity.
That's why I'm not saying. So in that case, I have to redistribute with a metric value. Let's do that. Rotary EHRP 10, redistribute OSPF 10. Put a question mark. Here you have to queue the metric one by one. EHRP has 5 metric. Bandwidth, delay, load, reliability,
Load
MTU.
and development.
Exactly. So here the delay may be just configure randomly. 100% reliable, 255. Load, let it be 1. MTU, maybe 1500. Okay. Now if I go ahead and check in R9, no, I do see it because I configured a metric now. So this is the function of your seed metric.
Yeah.
Yeah. So what is it left with? Uh, so distribution is done, virtual link is done, neighborship is done. Database, let's check out the database in R1. Show IP OSPF, show IP OSPF database.
Database.
So here you will see a hell lot of information. If you go and check on your area 0 LSAs. So area 0 now has how many LSAs? It has 4 LSAs. And you have to make sure the advertising authority is right for everything. So just for some small information, do I see anywhere 59 here?
No.
I don't see 59 here. We go to R3 and check. Show IP OSPF database. Do I see 59 here? Yeah, here I see
Yeah.
59. R2, about R2. Show IP OSPF database.
I think no.
Yeah, no, we should see now. I told now type 5 LS,
Okay. Yeah.
it goes everywhere. Domain.
Everywhere.
Yeah.
Okay. Okay.
R1, I'm not seeing it. Not sure why. If it is coming to R2, it should go to R1. Let me check why. Show IP OSPF neighbor. It is down. That's why. Why it is down?
Okay.
Something we did, it seems. Can I ping 12.001? I can ping. Show running configuration section OSPF. It's nothing special here. Maybe R1 has something. Show running configuration section OSPF. Nothing special I did. Okay. Show running of show IP interface brief. My interfaces are up. 12.001 is up. Show IP OSPF interface. Show IP interface brief. Interface also up. Show IP OSPF interface FA0/1. 1040 is my timer here. How about this
Yes.
side? Show IP OSPF interface FA0/0. 1040. Mine is broadcast. This side is also broadcast.
Broadcast.
What would be the issue? Mine said DR is okay. Of course, this side will be DR. Check one more time. Show IP OSPF neighbor. Oh, MTU mismatch. We want to configure something bad, right?
Yeah.
Interface FA0/0. MTU. You can guess it is MTU issue when you see exchange or an exstart states. So whenever you see exchange exstart state, there is an MTU mismatch. So that's why show IP OSPF neighbors. What is up? Show IP OSPF database. I should see 59 now. Now one small information.
Yes.
So I'm seeing 59 network, but who is advertising it?
5.5.5.
And who is that 5.5.5.5? My ABR router. I'm sorry, my ASBR router. Now, what if I don't have reachability for my ASBR? And who is giving my reachability for ASBR? My my own router, it says, because I am also an ABR router. Now, if you check on R2, which is here middle, show IP OSPF neighbor, sorry, show IP OSPF database. Here, if you check my advertising router ID, who is 5.5.5.5. So your type 5 is advertised by whom? 5.5.5.5, which is ASBR, right? But your to reach that ASBR, my who is advertising router ID? 35.003, who is my ABR router. So what I'm trying to say, your type 4 will be advertised by my ABR router and type 5 will be advertised by ASBR router. If I don't have type 4 LSA, in that case, you cannot reach this. Why? Because the 5.5.5.5 itself is given by type 4. If you can't reach 5.5.5.5, is it possible to reach this guy who's advertised by this guy? No, it is not possible. So that's why type 4 and type 5 should always be present. Okay. That's it. So yeah, I also need the recordings. You can have a look at it again.